Hi, this is Alex from devstories.eu. NumPy, episode 6 of 7. Grabbing every negative number from a billion-item array is not a search problem. It should not require a loop, and it certainly should not slow down your application. This is where we use precision filtering, Boolean masking. Basic slicing grabs neat, predictable chunks of data, but real-world data is messy. You rarely just want the first 10 items. You want specific elements based on a logical condition, and those elements might be scattered randomly throughout your dataset. In NumPy, grabbing data this way is called advanced indexing, and Boolean masking is one of its most powerful forms. Take a massive array of temperature readings. You need to isolate only the values that drop below freezing. Instead of writing a loop to check every single reading, you use a mask. A mask is an array of Boolean values, meaning true or false. Crucially, this Boolean array has the exact same shape as your original data array. You create it by applying a less than 0 condition directly to the array. NumPy instantly evaluates every single element. If a temperature is below 0, the mask records a true at that exact position. If the temperature is 0 or higher, it records a false. Once you have this mask, you apply it back to the original array by passing it exactly where you would normally put an index. NumPy reads the mask, picks out every element where the mask is true, and drops the rest. The operation yields a brand new one-dimensional array containing nothing but your freezing temperatures. It happens in a single step, pushed down to highly optimized C code under the hood. Pay attention to this next distinction because it trips up a lot of developers. You need to know exactly what NumPy hands you back when you filter data. Basic slicing returns a view. If you slice the first 10 elements of an array and modify them, the original array changes. Boolean masking behaves entirely differently. Because Boolean masking is a form of advanced indexing, it always returns a copy of the data, never a view. The reason is memory architecture. When you slice, NumPy just changes the pointers to an existing continuous block of memory. But when you apply a Boolean mask, the elements you select are completely arbitrary. They do not sit neatly next to each other in memory anymore. NumPy has to gather them up and allocate new space to store the result. This means if you modify your newly filtered array of freezing temperatures, your original dataset remains completely untouched. You can also chain these conditions. If you need temperatures that are below freezing but strictly above -10 degrees, you combine the two logical conditions. NumPy evaluates the combined logic element by element and builds a single precise mask. When you apply a Boolean mask, you are trading the memory efficiency of a view for absolute filtering precision, giving you a pristine, independent copy of exactly the data you asked for. That is all for this one. Thanks for listening, and keep building.